Practice and study of learning to incorporate instruction on formulation of consideration description under peer evaluation activity, focusing on scientific expression in description of consideration. Shinya Yamauchi of Graduate School of Education, Shizuoka University, Japan will give a presentation. Here is a consideration description written by one of the students. This consideration description was based on the redox experiment of copper oxide and charcoal. The student described it as gases and liquids were generated. When the compound of copper oxide and carbon was heated, it turned from black to red. The amount of consideration description is small and the content is insufficient. Here is the consideration description that the student wrote after the instruction on formulation of consideration description under the peer evaluation activity. The student described it as the white color of the lime water indicates that the gas generated is carbon dioxide. In addition, the material after heating showed a metallic luster when rubbed, indicating that it is copper. The reason for this is that the oxygen was taken from the copper oxide and oxidized to form carbon dioxide. The oxygen-deprived copper oxide was reduced to copper. The amount of consideration description has increased. Furthermore, the content has been improved to include results, data, claim, conclusion, and evidence, reason. In the time that follows, I will explain this learning process. I will proceed with my presentation in the order shown here, flow of this report. This section describes background of this study. Japan's Ministry of Education, Culture, Sports, Science, and Technology, MEXT, has proposed a direction that aims to realize optimal individualized learning and collaborative learning that will bring out the potential of all children. However, many problems have been reported in the consideration of science education to date in the realization of collaborative learning. For example, in a report by the MEXT and National Institute for Educational Policy Research, NIR, in the National Survey on Academic Achievement and Learning conducted in FY 2018, when asked, "Do you explain or present your ideas and thoughts to others in science class?" The results show that 58.5% of the students answered once a semester or more and rarely or not at all. There is one issue such as less collaborative learning in consideration process. Furthermore, as for the consideration description in science education, it has also been pointed out that there is an issue with the lack of scientific expression. NIR, 2019, shows that in Japan's results for scientific literacy questions in the OECD's PISA survey in 2018, the percentage of correct answers for explaining phenomena scientifically and argumentation is low. Therefore, as one of the efforts to solve these problems, we focused on learning instruction that incorporates the instruction on formulation of consideration description under the peer evaluation activity. The peer evaluation activity is a learning activity in which learners use GoTo's 2013 mutual evaluation sheet to exchange opinions with others about their considerations in observations and experiments, using the evaluation criteria to conduct self-assessment and peer evaluation, and then revise and improve their consideration based on the mutual evaluation sheet that shows their score evaluation and comment evaluation. It shows the learner doing the peer evaluation activity. You could see learners explaining their consideration descriptions to their friends and engaging in collaborative learning. In previous studies on the peer evaluation activity, it has been found that they are effective in increasing the awareness of explaining one's own considerations and revising others' considerations. But it has been reported that the peer evaluation activity is challenges in writing about evidence, which is one of the components of argumentation. Therefore, in this study, we thought that by using a learning method that incorporates the instruction on formulation of consideration description under the peer evaluation activity, we could aim at fostering scientific expression while realizing learners' collaborative learning. The instruction on formulation of consideration description means, as Matsubara, 1997, Indicated, I thought, conclusion, from, results. The reason for this is that, evidence. By using this learning, we thought that we could achieve collaborative learning in the consideration of science education, while also aiming to develop scientific expression. Here is a definition of scientific expression in this study. In science education in Japan, there have been recent reports on the practice of introducing argument by claim, data, reason, background, limitation, and refutation, which are the components of Tolman's argumentation structure. Matsubara, 1997, clarified the structure between Tolman's model and the formulation of consideration description. Results, data, claim, conclusion, and evidence, reason, are important elements in the consideration description, but background, limitation, and refutation are not always necessary. In this study, we supported this previous research and defined scientific expression as a text that includes results, data, claim, conclusion, and evidence, reason. This section describes purpose of this study. The purpose of this study was to implement a junior high school science class that incorporated the instruction on formulation of consideration description under the peer evaluation activity, and to clarify the effects on the development of learners' scientific expression. This section describes research methods. First, students do an investigation question to investigate the first scientific expression. Next, students do a lesson with an experiment and write a consideration description on the learning task. After that, students rewrite their consideration description after learning to incorporate the instruction on formulation of consideration description under the peer evaluation activity, and then they do a second investigation question with the same content after the class. Then, we analyze the student's consideration description and the two investigation questions, and discuss the development of scientific expression. Here's a look at lesson with an experiment, a combustion experiment of magnesium in carbon dioxide. After the experiment, we set a learning task called magnesium burned in carbon dioxide, producing a white substance and a black substance after combustion. The white material lost its metallic luster. Write a consideration of these facts to explain the changes that occur when magnesium burns in carbon dioxide and ask the students to write their consideration description. An example of an appropriate consideration description was after combustion, a white substance and a black substance were produced, and the white substance lost its metallic luster. This suggests that when magnesium was burned in carbon dioxide, it was transformed into magnesium oxide and carbon. The reason for this is that magnesium took oxygen atoms of carbon dioxide and oxidized it, and carbon dioxide was deprived of oxygen atoms from magnesium and was reduced. We will show for the investigation question. For the investigation question, we set a discussion of the redox experiment of copper oxide and charcoal, which is a content related to the lesson with an experiment. Table 1 shows the investigation question, and Table 2 shows the evaluation criteria for the investigation question. The evaluation criteria consisted of 6 items. Items 1 and 2 are results, data. Items 3 and 4 are claim, conclusion, and items 5 and 6 are evidence, reason. An example of an appropriate consideration description was the gas produced after heating made the lime water white, and the red substance left in the test tube after heating glowed when rubbed. This suggests that when copper oxide and charcoal powder are well mixed and heated, they are converted to carbon dioxide and copper. The reason for this is that carbon took oxygen atoms of copper oxide and oxidized it, and copper oxide was deprived of oxygen atoms from carbon and was reduced. This section describes analysis. An example of the consideration description before and after the rewrite is shown. Before the rewrite, the consideration description related to one of the results, data, it became brittle and lacked luster, and the claim, conclusion, it was transformed into another substance was found. The rewritten version added the results, data, of a black substance and a white substance were produced, and the evidence, reason, for oxidation reduction. Thus, we can see that the learner's consideration description about the results, data, and the evidence, reason, has been improved by the instruction on formulation of consideration description under the peer evaluation activity. A pre-post comparison of items was conducted on the first and second investigation question, McNamara test, two-tailed. As a result of the analysis, there was a significant increase in items, 5, concerning evidence, reason. In addition, there was a significant increase in items, 2, concerning results, data, and items, 6, concerning evidence, reason, by the 10% level of significance. However, no statistically significant differences were found for items, 3, and 4, concerning claim, conclusion, Table 5. From this, we can say that we have improved on results, data, and evidence, reason, in scientific expressions. This section describes conclusions. In this study, it was suggested that learning to incorporate the instruction on formulation of consideration description under the peer evaluation activity had the effect of promoting the improvement of the consideration description, including results, data, and evidence, reason, that constitute scientific expression. In the future, it is our task to examine the advantages of learning to incorporate the instruction on formulation of consideration description under the peer evaluation activity by comparing the three groups: the group with only the peer evaluation activity, the group with only the instruction on formulation of consideration description, and the group with both. This concludes the presentation. Thank you very much for your attention.